Ingeteam Power Technology. Power Grid Automation. Tutorials. Topic: Local Display Editor. In this video, we will learn how to configure the local display of an IED with the Energy Factory Suite tool. The local display can be configured from 3 of the applications in the EFS tool: POC Factory, Substation Factory, and IED Factory. The first application, POC Factory, lets the user configure the local display of a single IED. In order to access the local display editor, we first need to open the application and select the IED whose display will be designed. Then, in the configuration drop-down menu, the local display editor will be available. In addition to the tag in this menu, the local display editor can also be accessed from the column on the left. The second option, Substation Factory, does also let the user configure the local display of a single IED. There are several tags and buttons that let the user access the editor, for example, the INGAPOC drop-down menu. Lastly, the IED Factory application does also allow us to configure local displays, but not for single IEDs, for IED templates instead. The local display editor can also be accessed from the INGAPOC drop-down menu. When working with default CIDs or non-IED specific configurations, the applications in the EFS tool will let the user select the type of local display. In this example, we will configure the local display for the IED template from IED Factory. First, we will save a blank page in order to name it. This page will be one of the 9 customized screens that can be configured and sent to the IEDs. In this screen, we will represent the disconnectors and breaker of a busbar coupling position. First, we will draw the line which will represent the busbars and their connections to the circuit breaking devices. For that, we can use the line symbol on the left side of the toolbar. The breaking devices symbols will be imported from the symbol next to the C and M tags in the middle of the toolbar. First, busbar A's disconnector will be included. For that, we will need to look the corresponding signal up by clicking on the status button. Additionally, the disconnector will be commandable from the local display, so a command priority and the corresponding model variable must be assigned to it. Then, in the selected group drop-down menu at the bottom of the window, the symbol for the disconnector will be chosen. Next to the drop-down menu, the C button will show how the symbol would look like in its possible states. At last, we will save the configurations done to this disconnector symbol. This same procedure will be repeated for the coupling breaker and busbar B's disconnector. As opposed to busbar A's disconnector, that of the busbar B will also be a grounding disconnector. Therefore, its symbol will be drawn following the value of 2 double position signals, one for the busbar disconnector part and another for the grounding disconnector. In order to enable the double signals, the more than one element checkbox needs to be selected. The last configuration for this disconnector will be the selected group, the symbol, which needs to be suitable for the more than one element option. Once that busbar B's disconnector has been configured, we will properly arrange it in the SLD, and we will attach the ground symbol to it. In addition to the circuit breaking devices, an indicator will also be included in the SLD screen, which will be used to show the status of single-point status signals. Much like with breakers and disconnectors, indicators will also be configured from the symbol in the toolbar. In this example, the local/remote signal will be assigned to the indicator, which can also be commandable. By clicking on the A tag on the left hand of the toolbar, fixed text boxes can be included to the screens. Next, we will design a screen for the measurements. In order to include any measurement model data, the M tag in the toolbar needs to be selected. From this window, in addition to selecting the signal, this can also be formatted: decimal numbers, units, low and high value alarms, number of digits, and more. For this example, in addition to the phase currents, the phase voltages and neutral current and voltage will also be added to the screen. Once the homemade screens are designed, this need to be included in the display's configuration. For that, we will need to include them in the screen order configuration listed in the configuration drop-down menu. From the screen order configuration window, the pre-made and customized screens order will be configured. The screens listed to the left will not be included in the configuration sent to the IED. Those to the right will be included in the IED's configuration. Therefore, in order for the customized SLD and measurement screens to be included in the IED's local display configuration, the one-line diagrams tag needs to be moved to the right with the arrows in the middle of the window. In addition to configuring the order of the customized and pre-made screens, the appearance order of the customized screens can also be configured from the graphic screen order tag in the configuration drop-down menu. As it can be seen, by shifting the customized screens in the graphic screen order window, these will have also been shifted in the configuration file. In order to send the configuration to an IED, we will first need to save the configuration, and then send it from the Tools drop-down menu. Finally, we now know how to configure the local display of an IED with the Energy Factory Suite tool.
InduTeam, electrifying a sustainable future.